So for proofs, you could be asked to prove something, which you've been asked on the homework. I've done some in class. So I tried to put a summary together of just being kind of explicit about what I would expect that you could do on a test. And so from 3.1, we had the derivative of a constant rule, and the proof is on 174. I also did a bunch of these in class too, so but I try to put down ones that are in the book too. So constant multiple rule would be another one. I think we did that one in class. The sum rule, the difference rule, those are all pretty straightforward. From 3.2, we did the product rule in class. And that was a partial proof only that I would expect you to do. Also, I think this one appears maybe on the practice exam. Am I right? It's either the product or the quotient rule. I can't remember which one is on the practice. But like the quotient rule, you had to finish a proof for the quotient rule on the homework. Remember that? Where I did the kind of the tricky algebra steps for you and then just said finish it. So for the quotient rule, you could expect to have to do basically what you did on homework 4, pretty much verbatim, or kind of in a similar style for the product rule, which I did the whole thing in class, but I would probably, this is the part I would have for you in the style of what you had on the homework for the quotient rule, and then tell you to finish it. Does that make sense? So this is how I would do this. I'd say, you know, if big F of x equals little f of x times g of x, then by the definition of a derivative, f prime of x equals, by definition, limit as h goes to 0, you know what that derivative is, and then kind of that initial step where we plug in what big F is, and then the tricky algebra step. And then I stop, you finish. 3.3 was trig functions, and oh, I should erase this like quiz 4 thing, so I don't think, oops, VGA's spazzing out here. So here you had a homework problem, and I did one in class where you had to show something like the derivative of tangent is secant squared, and the idea here for all of these is we didn't do a proof of sine and cosine because those are really hard to do actually. We kind of went over some justification for why their derivative rules are what they are, but then once you have the derivative rules for sine and cosine, then the rest of the trig functions, you can prove their derivative rules by setting them up as a fraction and using the quotient rule, all of them. And so we did one in class. You had at least one on the homework. 3.4, we did a little derivation of the derivative rule for exponents when you have a to the x, like an exponential function. And this one I would give you a little bit of help again because there's kind of a tricky initial step where we write a to the x as e to the ln of ax, a to the x. And then I would even maybe give you that next step where you have to use the exponent or the log properties to bring down the exponent x and write it as a product times the natural log of a, and then have you finish it or something. So that derivation's in your book on page 203 if you want to see the rest of it. So that's all I had about proofs. I just wanted to kind of give you an overview of what I would expect that you could be able to do on the exam if I ask a proof question. So any questions with regards to proofs? Yep.
What majority of the test is it?
What's that?
How much of the test is it, roughly?
At the most, one question. So either I'm going to ask you a question to do a proof or I'm not, like one or the other. I won't say either way, but at the most one question, at the very most. Yep. So 3.9 is the related rate section, and you will be asked at the most 2 questions on 3.9. For sure 1, up to 2. In the past I've asked 2 full related rates problems. But more often than not, I either ask one or I ask two questions, but one's a full problem and the other one's like a multiple choice style. And you saw that hopefully on the practice, or if you haven't, you can look at an example there on the practice of a related rates problem that is just asking not the full related rates problem from 3.9, but some like type of reasoning from that section for a problem that has like cars that are moving, and you have to say like what variable changes with time and which ones do and don't, basically, in a multiple choice format. So sometimes I ask like a full, I mean, expect for sure a full out problem like you did on the quiz with number 1, like a full problem from 3.9, and then you might have like a little extra multiple choice, or you might have 2 full problems. Yep.
So you're going to want to know the proof for the quotient rule and the problem?
You should know both. And you should know it from the step that I have shown in the notes here, from the product rule, where it's like where I left off, you would have to finish that. Because I did the whole thing in class, so you wouldn't know where I left off, so that's kind of why I wanted to highlight that. And then for the quotient rule, it'd be just like homework 4, if I ask that. So, other questions? Yep.
The 3.9 on the quiz, is that of similar difficulty to the test, or will the test be a little easier or a little harder?
It could be, it varies. I mean, it won't be anything harder than what you've had on homework or other sources. I'd say that problem is, I mean, that would be fair game to have a problem of that difficulty on the test. Especially since that was the exact same problem from the notes with numbers changed. You know, so it's like it should be kind of familiar. So yeah. Other questions? It's good questions you're asking. Feel free to ask more questions, but I'm going to stop this recording.